So in Chapter 19, we're learning all about what are called confidence intervals. So when we were working in our last video, we're exploring this idea that we took a survey, we got a sample proportion, but we wanted to know the truth. And I ended with a sentence that looked like this. We are 95% confident that between 38.2% and 49% of all Granger High School students like the school lunch. So we call them confidence intervals because I'm ending with an interval of possible values, and confidence because of this confident phrase that I use. So what I'd like to explore today is, what if instead of 95% confident, I wanted to be 99.7% confident? So hopefully in your mind you're thinking, aha, 99.7, I know that number. We think back to that normal model we constructed. In order to get the 95% confidence, I went up and down 2 standard deviations. Right? That's where those values came from. So if I want to be 99.7% confident, I need to change the number of standard deviations I'm using. Instead of 2, I'm going to go up 3 and down 3. So I'd have a new interval. I'd be 99.7% confident that it's between 35.5% and 51.7%. All right, so that's the idea. I'm going to change the number of standard deviations. Now, we don't want to always be stuck counting and drawing pictures. So there is actually a formula for creating a confidence interval. And unfortunately, my markers just do not have these hat things on them. Excuse me, my font when I type these. So when we create a confidence interval, we're going to start with p hat. Right, that's our estimate. That's what was in the middle of the picture. And we're going to add and subtract this thing called z star. The z star is what I was trying to show in the last picture. It's just the number of standard deviations we're going to use. So do we go up 2? Do we go up 3? Maybe something in between. And we multiply that by a standard error. Standard error is just a fancy name for this formula that we've been using already for calculating. Instead of calling it standard deviation, because we're estimating with our p hats and our q hats, they call it standard error. Doesn't mean mistake, just that's just the name. So I want to go ahead and show you kind of how this works. So for the last example, our p hat, make sure I get this correct, was 0.436. I'm going to add and subtract. Well, let's do the 3, right, because I wanted to be 99.7% confident. So I'm going to add and subtract 3. Right, we're thinking in our brain, that's what is here in red. I need to go up 3 for 99.7. And then times that standard error value. We did this already. It was the 0.436 times the 0.564 over 330, because that's how many people I asked. Now, we do know already that this number right here, the big, long, messy-looking one, so I'll just simplify that. It was about 0.027. So go ahead and try that out. If you subtract, so if you do the subtract, you're going to get the 0.355. So we're going to end up with an interval. I like to write my intervals this way. And if you add, you're going to go up, and you should end at the 0.517. Now I did round a little bit, so if it doesn't come up perfect, my apologies. All right, so that's the idea of using this formula. But it would be pretty silly if we were stuck just doing 2 and 3 standard deviations. So we're actually going to explore some more options there. What if I wanted to be 90% confident? I don't really know where 90% is on this picture. Right? If I do only 1 standard deviation, that's 68%. So it's going to be somewhere in here. I don't know. So we're going to check this out. Imagine, just for a minute, the normal model. If I want to be 90% confident, from the mean, I'm going to go up and down some number. So then I end up with 90% in the middle. So let's see. There's 100%. I'm just going to use 1. I'm going to subtract the 90%, or 0.9. That leaves me 0.10 left. that is not in my picture yet. But that could be on this side or on this side, right? There's two tails, so I need to split that 0.1 between the two tails. So I'm going to divide by 2. That gives me 0.05. So that means on my picture, this piece is 0.05. As a matter of fact, so is this piece, 0.05. Now you may or may not recall there's something cool on your calculator that if you tell it the percentile, the percent that's in this left-hand piece, it will actually give you the z-score. That was our inverse normal function. So let's go ahead and take a look at that. All right, so we go to the distribution, and we select inverse norm. And I'm going to tell it the percentile, or the left-hand tail. Make sure it's a decimal. And it goes ahead, and it will give me how many standard deviations that is. What is the z-score? So right here it says negative 1.64. Just going to use 2 decimal places. Something that I want you to be aware of forgot it won't let me write on both of those at the same time. Something I want you to be aware of, when this is representing the how many do I need to count. Like we counted 2 or we counted 3. Well, now we're counting 1.64. So I'm just going to always consider these positive numbers. This is actually the z star that you saw on that formula, z star, the number of standard deviations. And we call it a critical value. And again, I list them always as positive. Mathematically, it will come out the same even if you include a negative in the formula, but it's just a matter of convention. That's the way statisticians do it. Okay, so let's check out another one of those so we can practice what it was I did there. What if I want to be 92% confident? Well, I'm going to sketch the normal model. If I want to be 92% confident, that means there's 92% in the middle area, or 0.92. So if I subtract that from 1, that leaves me with 0.08, but I need to split that between the 2 tails. So I'm going to split it into 2. That leaves me 0.04. So in this tail is 0.04. Now I look that up with my calculator to find the z-score. I go to my distributions, my inverse norm, and I type in the tail area. So we get 1.75. Remember, these ones, we just always call them positive. 1.75 is my critical value, or z star. All right, so just one more to take a look at. What if we wanted to be 95% confident? Well, I know you're thinking that's 2. We know that already. Well, let's check it out. I'm going to find out that I've been lying to you this whole time. So I put 95% in the middle. I subtract that from 1. That means I have 5% left over, or 0.05. I have to split that between the 2 tails. So that's 0.025. So right here in the tail, 0.025. If I go ahead and try that out in my calculator, we're expecting it to be 2. It's not 2. It's 1.96. Oh, this whole time I've been lying to you. Okay, I just rounded. But it's important. I need to point this out. You can't use 2 anymore for 95%. You have to use 1.96. We're going to start getting a little more technical. If you use 2, you will lose points on the AP exam. So we're done with our rounding days. It's actually not 2 standard deviations up and down. It's 1.96.